Hi, good morning, everyone. My name is Vidya Sagar. In short, you can call me Vidya. I'm working as a pre-sales consultant for AWS in Redington for a KSA region. And first of all, I thank you for joining with us today. We try to give you as much as possible information about AWS in this session. So you can feel free to ask any questions in the chat box. We'll try to answer maximum questions. And today our agenda is displayed here. We're going to introduce introduction about AWS Cloud, what is AWS and what services we are offering and all stuff. And the second is global reach. What is our global reach in terms of? So next agenda is going to be talk about AWS main services like compute, network, and storage and database. And there is a advanced services also available in AWS, like 200 plus services we are offering. We're going to brief you short in advanced services, and last we have Q&A service available also there. First, we're trying to understand what is AWS. So in everybody's mind, like when we are talking about something, we have to understand what is the full form of the company, then what they're just generally offering to the customers. So AWS stands for Amazon Web Services. So which is offers uh, web services in terms of what to provide by the Amazon that uses distributed IT infrastructure to provide a different IT resources available on demand. It provides different services such as infrastructure as a service, platform as a service, and packaged software as a service. So everybody aware of that infrastructure as a service. That infrastructure as a service means compute, storage, networking. All this falls under infrastructure service. And PaaS is something deploy with operating system and application level is going to be PaaS. Or is any full-fledged service is going to be offered. Like for example, AWS has something called marketplace, where there are other companies offering you with a full-fledged solution like SAP. So that is comes under SaaS model and all stuff. So Amazon launched AWS, a cloud platform to allow the different organizations to take advantages of reliable IT infrastructure. So this is AWS. So AWS offers infrastructure as a service and platform as a service and SaaS model are available. So what is the use cases? Why we have to go to AWS? Simply, for example, take an example of a media company can use AWS service to provide a different type of content such as ebooks or audio files to the worldwide files. Example, if for example in a media company is established globally, for example BBC News example. So there is a content is stored in one data center, but they have a different branch location in other countries as well. How the content is moving to other locations and all because of a AWS service example. So they will share the data in between their storage units, and whenever they need it, they will collect the data from the particular region and they will telecast to the particular country or so on. So it's an example of a media company. For example, if you take an architectural company who is in construction basically, can use AWS, get a high compute rendering machines for construction prototype. So they can use for rendering their applications. They can still can come and use AWS service. We've typically taken IT enterprise customers, like for example, you are running an SAP application on premises. So that same application can run on AWS as well with more performance, more advantages. What is the difference will come in a physical infrastructure and AWS infrastructure is in physical infrastructure you have to invest more on the cost of the hardware upfront, and you have to plan over 3 years of increasing the memory capacity and all, and you have provision on the hardware. But in AWS case it is not that. You can start as low as possible. Later whenever the need is required, then you can increase the capacity. And another advantage what you can see here, pay as you go model. The pricing model is pay as you go. That means you no need to invest anything upfront. For example, if you take an hardware infra, you have to pay upfront and you have to provision everything upfront and you have to plan before. In AWS case, no. Whenever you require, there is no prior commitment is not required. There is no upfront investment is not required. Whenever whatever you use, pay for that particular service only. So what kind of services are available from AWS? Like compute you can take, programmable you can take, database storages you can take, and networking also you can offer. Another beauty of AWS solutions is flexible and cost efficiency and scalability and security. These are the four key factors AWS follows and offer you flexibility. Flexibility in terms of hardware. As explained, infrastructure whenever you need it, you can acquire and increase and decrease the capacities. That is possible in flexibility. Cost effectiveness. What there is no long-term commitment required for AWS. See, for example, today you required a test environment need to be readily available. This is only for 6 months or 1 year. You can take that particular instance for that particular time frame, and you can work and you can close the business for test environment. For scalability, for example, when you consider scalability, uh, just an example you take as an e-commerce company. So you planned as a physical infrastructure, you planned for 1,000 users. There is a spike of another 1,000 users are joined to the site, for example, e-commerce site. So what will happen? The infrastructure of physical only supports 100,000 users, but if another 1,000 had it, then there will be a crash in the physical data center. But in the same case, coming to AWS is not the same case. What will happen? We have something called auto scaling feature available. So whenever the 1,000 user you can plan now, tomorrow there is a season is coming, a particular function festival is coming, and during that time you are assumed that there are more users are going to add to the system to do the shopping of online and all stuff. So you can put the particular time frame for auto scaling group, so that whenever the spike is happen, whenever more users are try to connect the website, immediately AWS services will be attached in auto scaling group. Then it will support another 1,000 users also. Once the 1,000 users are reduced, automatically the auto scaling group, from the auto scaling group we can remove the instances. So that is the scalability we can expect from AWS. Security is the major pillar for AWS to offer confidentiality and integrity and availability of the users data. So that is more secure when it comes to security. So these are the key advantages of AWS. Now we understand what is AWS and what are the advantages we can expect from AWS. So there is another benefit is we are talking about is, so if you see the history of AWS, we started our company in 2006 as a AWS services company. Then right now we are having uh, you can say there are 200 plus services we are offering on the same cloud platform itself, and we have 24 regions and 76 availability zones and 216 edge locations. So in coming slides we are going to talk about what is region, what is availability zone, and what is edge location. And you see our pricing philosophy is that whenever we launch a new service, that will be when you compare with the old service, the prices are less. So that is the pricing model, and as low as possible with the services, what new features, new advantages we give in a less cost. That is the beauty of AWS technology solution. See, we are Gartner leader quadrant, and we are the top leader quadrant in the web services field. So, and this is our global reach. So now we are talking about what is global reach and what is a region and what is availability zone and what is edge location. First, region. Region is a geographical area. So it's a geographical area. For example, you can see here, United States is one geographical location. We call it as a region. And another example we can do, North Virginia is one region. We have Canada. We have Central is one region. In coming to our Middle East, is Bahrain is our region. So a region is a geographical location which is completely isolated from another region. For example, Bahrain and United US East is North Virginia is a different region and Bahrain is a different region, and each region contains two or more availability zones. So each region contains two or more availability zones. What is availability zone? Availability zone is nothing but a multiple data centers clubbed together, close together is form a availability zone. So what will be there in availability zone? It's a purely a data center completely, which comes with multiple servers, switches, load balancing, and firewalls, and so on. So and cables and etc. we are talking about. So which forms availability zone. So in each region we have multiple availability zones, and multiple availability zones have a multiple data center, and we have a fully high backbone connection between these availability zones, and it is fully high available. And coming to the edge location, what is the edge location? Edge location is nothing but, for example, we are using a YouTube channel. Okay, when we are playing a YouTube channel, some video is whenever you request for some video, it is telecasted on YouTube immediately. How it is available? Because of this edge location. Edge location contains a caching mechanism. So what is cache? It will be keep the information how much is possible and near to the users. So we have 200 plus edge locations. Inside edge location, we use called something called CloudFront, and there is something called CDN. What is meaning of CDN? Is Amazon Content Delivery Network. So because of the CDN network only, right now, whatever shows we are watching on Netflix is the biggest customer for AWS, and Amazon Prime also is one of the thing. Whenever you demand, one video is telecasting because of CDN network and all stuff. So this is about regions and availability zones and 200 plus edge location we are carrying, and our network is vast, and we follow 47 critical certificates and compliance program from the global authorities. For example, ISSO is one of the biggest authority to certify whether your company is properly set up or not, and something called CSA is the Cloud Security Alliance. So it's take care of the security activities and all stuff. So we follow 47 critical certificate. So that's why this proves that how much we are capable enough to handle our services to end users. And moreover, about our uh, global reach, wherever we build a region availability zones, we have our own backbone network is established entire the globe. You see, this network is managed by ourselves only. We don't depend to any third party company, and the complete maintenance is taken care by AWS. And each availability, I mean each region is connected with backbone and high availability connections between two different links. And a simple example of availability zone, how they look like. So if you consider an example, this is the AWS region, and we have a multiple data centers forms a availability zone. So in this example, we have considered four data centers in availability: AZ1, AZ2, AZ3. So they all interconnected, they are high available, and they form a full region. So now we finished global reach, and we understand what is availability and what is AWS network, how strong we are in the networking area. Now we are going to talk about what are the services we offer. So in typical scenario, we are considering the choice of compute is available in three varieties. I mean, I can say the instances types I'm talking about. So EC2 is a primary. Whenever you requested a basic instance, that is available from EC2 only. So we talk about an application to deploy or to build a server, whatever, we start with EC2 instances. So EC2 is nothing but it's called Elastic Compute Cloud. What is the use of EC2 is? EC2 is simply a virtual server. If you see a virtual machine, a virtual server is in AWS, it is called EC2 instance. What to do in this? We can run an application. That in this EC2 instance, we have plenty of instances are available with different purposes. For example, you take a test environment and you want to run a development environment or something like that, we can recommend to go with the T series or M series kind of thing. What is we generally that named as a general purpose instance. And there are other instance for a compute power. For example, you want a computer optimized instance. There is something called C instance are available, and there's something for a memory optimizer. For example, you want to run an SAP instance where you require more memory application kind of thing, we use memory optimized instances. And you want to run some graphical GPU intensive applications, you are doing a rendering application kind of thing, there is something called accelerator compute instances are available. If you want a big data Hadoop kind of setup you want to run in your data center, or you want to run from AWS for the service, it is available with us as well. It's called storage optimized instance on i3. So there is another concept called Amazon ECS and EKS and Fargate. So I just give you a brief idea of what it does and all. Amazon ECS is nothing but ECS is a elastic container service, is highly scalable and high performance container management service that supports Docker containers and allows you to easily run applications on a management cluster of Amazon EC2 instance. See, tomorrow you want to run any container, so Amazon itself the container service is available, which you can use and you can run your container service. EKS is nothing but it's a Kubernetes service. E means Elastic Kubernetes Service, which is a Amazon offering that helps to running the Kubernetes service on AWS without required the user to maintain their own Kubernetes controller plane. So it is a fully managed service by Amazon. So it's completely fully managed service available. Fargate is nothing but is a serverless compute engine for containers that works with both ECS and EKS. So Fargate is a serverless architecture to run the containers engine, and it can work with both ECS and EKS. What is Lambda? Lambda is a purely serverless computing. So what advantage you can get from Lambda is when comparing with EC2 and Lambda. In EC2 you have to run operating system, you have to run application on top of it, and you are, for example, you are using for a testing environment, you have to run the code. To just run a code you are taking entire EC to run it. To avoid that kind of huge investments, Amazon launched something called AWS Lambda function to give you and to run your code, just for running a code and enter a code and run it on a Lambda functionality. The beauty is whenever you run a code, then only you are chargeable for the instance. Whenever you don't run the code, you are not going to charge anything. So that is the beauty of Lambda functionality. So in the next slide, I'll just brief you about what are the EC2 instances are running. Why we are stressing EC2 more is because tomorrow you want to launch any instance, or tomorrow you want to do any test in infrastructure, the EC2 is the main component. We start with the operations. So we have, as explained to you in the earlier slide, it is called general purpose disk and compute optimized and memory optimized, and these are the use cases why we use uh, general purpose and why we use computer optimized devices. For example, you take a memory optimized device, is running for a SAP application kind of scenarios, all this stuff. I'm moving on to next slide. So what is inside the EC2? EC2 comes with an operating system flavors of like Linux and Windows, and we have an processor choices like ARM processor from AWS and x86 architecture, means Intel platform processor are available. We can run with the general purpose and workload optimized disks are available. So kind of thing. Next is what are the processor types are available in AWS is Intel is available, and NVIDIA is available, AMD also available, which is newly launched. There is a Amazon ARM based cloud processor also available, which is purely from Amazon. So you can choose what type of a processor is required for your application. And we are supporting these many operating systems in the EC2 instance and AWS cloud. Windows can start with 2003 R2 onwards and 2016. Amazon Linux is also available, which is purely Amazon developed this Linux. So there are other OS like SUSE, CentOS, and Red Hat Linux and Ubuntu. You can choose your operating system and can run on EC2 instance. And we are the highest percentage usage on Windows licenses as well as a cloud provider. So when you compare with the other cloud vendors, we are the highest, and it is 57.7% of occupation is there for Windows licensing in our infrastructure. And we offer these instances in three variety of pricing model, which can give you a brief idea about and how to use. See, that is called on-demand instance and reserved instances and spot instances. What is on-demand? On-demand is nothing but, so whenever it is useful for the application that have been developed or tested on Amazon EC2 for the first time. So for example, you are newly launching an application or something like that, and we don't have any idea how much hit is going to happen for this particular application, or how much of memory processor is going to consume for this. So in that case, we can recommend to go with on-demand instances, and you can deploy and you can opt for this pricing model. Reserved instance is, when comparing with on-demand and reserved, the prices are a little low when reserved instance, but there will be a one-time or 1 year or 3 years contract period will be applicable. The commitment of utilization will be there in the pricing model. So when we recommend this kind of instance, we have a very clear idea, and we know that till 1 year we can run this instance without any changes or something like that. At the time we can go for a reserved instance, then we can happily use with a less cost. Spot instances are basically for a time being, temporarily you want to use, want to run some coding kind of thing, and those kind of workloads we can come on under spot instances pricing model. So these are the three variety of pricing models are available in our EC2 instance model. Coming, we are talking about network services. In network services, whenever we start our own network on AWS cloud, so we use something called a VPC. So what is VPC? We start with the VPC. What is VPC? Virtual Private Cloud. What it does, it enable you to launch, create on your own VPC network. Is as simple as you are creating your own network on AWS cloud. The virtual network closely resembles a traditional network that you have operated in your own data center, with the benefit of using the scalable infrastructure on AWS. So this is VPC. So inside the VPC, once VPC is established, then VPC contains subnets, IP addresses, and all elastic IP addresses. Then on that, we are going to install the EC2 instance. On top of EC2 instance, we are going to install our application. So VPC is our basic network. In that, we have so many other components. We are going to brief you what is elastic IP. Elastic IP address is nothing but it gives you an internet access to your instances. For example, if your instance does not have a public IP, for example, your instance don't have a public IP, you can associate it on an elastic IP address. So instead of allowing all the instances to public access, you can take a particular access and attach that particular application with elastic IP address. Then that elastic IP address will allow the particular instance to communicate to the external world. So for example, it's allow you to connect to by your instance from your local computer. For example, from your local computer itself, you are going to connect it to your AWS instance. Another service we are talking about is Direct Connect. So AWS Direct Connect is a cloud service solution that make it easy to establish a dedicated network connection from your premises to AWS. Using AWS Direct Connect, you can establish a private connectivity between AWS and your data center. So it's simply saying, in AWS, you built your infra, your data center, and you're trying to connect from your office. Then we recommend to go with the direct connect. It will create a uh, private connection between your data center to AWS cloud. Then what is the advantage you can see from is about the latency. It will reduce the latency of reaching your application, and it is increase the bandwidth throughput as well. and provide more consistent network experience that internet-based connections. The next major component is going to be used as ELB. What is ELB? ELB is nothing but elastic load balancing device. It is an application, incoming application or network traffic across the multiple targets. So elastic balancer is going to do functionality of multiple targets going to be balanced. For example, you're running instances. For example, one instance is running. In case of any failure happens, you can create a policy to balance the load on the other instance, which can be happen through ELB. What you can do is it instances and containers and IP addresses in multiple availability zones. So it is going to manage multiple availability zones for all the EC2 instance and containers and IP addresses. In ELB, we have three variety of ELBs are available, which is like application load balancer and network load balancer and classic load balancer. What majorly difference between these all? Application load balancer we recommend when you are trying to deploy like HTTP and HTTPS application. At the time you can choose elastic load balance. You are only purely on TCP protocols, TCP networking kind of thing, then you can go with a network load balancer. Classic load balancer will give you very basic functionalities like TCP or HTTPS applications you can run on both, but in a minimal load kind of thing. Then we recommend classic load balancer. And another very important uh, uh, service is called Route 53. What is Route 53? Simply is a DNS service from AWS. What it does, for example, if it is www.abc.com is the company name, it will convert that company into an IP address like 192.168.0.2 kind of IP address solution. It's only do a domain name system. It will changes the domain to IP2 domain kind of functionality can be offered from Route 53. So these are the major components we generally use in AWS for offering a networking services. So I just brief you one more time. So whenever you start your network, you start with VPC. After VPC, you build on inside you create your own IP addresses range, and you can create your subnets and all. And on top of on the VPC network, you're going to create your EC2 instances. So whether you are going to allow the EC2 instance publicly available or it's only available only private use, those instructions all going to be can be done in VPC. So far we covered EC2 instances, what type of EC2 instances are available, and what is ECS and EKS, and what is Lambda. Then now we covered about what is the networking major components are used in AWS service, networking service. This is an example setup how we do as I explained to you. So you can create you can take availability zone A and B, and you can create your own private subnet, and one you can see the second diagram is allowed with public subnets and allowed to the public internet users. And now we are going to cover storage services. What are the storage services are available in AWS? So there are majorly three storage services we are offering in AWS. One, we can start with block storage and file storage and object storage. Block storage, we call it as a EBS. EBS means elastic block storage. Is a block storage system used to store persistent data, and Amazon EBS is suitable for EC2 instance by providing a highly available block level storage volumes. It has three type of volumes are available. Basically, we use general purpose SSD and provisional IO based SSDs, and simply a magnetic disk also available in providing a EBS volume. So depending on the usage and depending on our application performance, you can choose whether I have to go with SSD or if you require more IOPS intensive applications are running, then you can choose provisioned IOPS model of SSD. Or if simply you're running a small application, you don't require much intensity on the IOs and all, then you can choose for magnetic disk as well in block storage. So whenever we create a EC2, the EC2 will be attached to EBS volume. So that is the major importance we give to the EBS. And what is the EFS? EFS is nothing but elastic file system, which provides a scalable file storage for use with Amazon EC2. So you want to run any file system, you're going to use EFS. You can create an EFS file system and configure your instance to mount the file system, and you can use an EFS file system as a common data source for workloads and applications running on multiple instances. So this is basically a file service is going to run on with the ECS instance. And coming to the next storage is object-based storage. We call it as S3 buckets. What is the meaning of S3? S3 is simply storage service. Is an object-based storage service that offers industry-leading scalability and data availability and security and performance. So in this object-based storage, we can use images, and we can use for any data. For example, this is basically using for storing most of the times for a backup purposes. All these third-party company backup solutions are supported with S3 bucket. So in terms of cost wise or compared to the other EBS services, the cost wise also is cheaper. And in S3 bucket, we are having different versions are available on the retention policy basis. So these are the different type of instances are available, which is S3 object storage classes, we call it as. So what makes the difference is, so we have standard and infrequent access and one zone infrequent access, intelligent and glacier. So here the three S3 bucket object is common. These all are used, and the major difference between these all the three versions are retention time going to be changed, and when you are trying to archive the data, the time process is taking to archive the data also changes in these varieties. For example, you take a standard. In standard, the availability of SLA can be done with 99.9% can be done with a standard model of SLA. The data can be available in 3 availability zones. So minimum of 3 availability zones, our S3 bucket data can be available. In case one availability zone failed as well, the data can be available from other availability zones. And infrequent access also same, but what will happen, there is a 30-day minimum duration of millisecond access is there, is also available in 3 availability zones. And one zone infrequent access is only for 1 availability zone is available. And if you take a glacier, is again for 3 availability zones, but the data duration is for a glacier is 90 days, and rest of the buckets of S3 classes is going to be changed to 30 days. This is all going to be used for only object-based storages only. Okay, next we covered EBS, EFS, and S3 bucket and S3 bucket classes. So S3 bucket is very common in AWS. Whenever you heard from your colleagues or other company mates, so S3 is very common in using for a backup, archival purposes and all stuff. And these are the a glance of AWS storage options. We already discussed about AWS block storage, elastic files, and S3 and Glacier. And AWS, another component is called storage gate. Storage gate is a service in AWS that are connected an on-premises software applications with the cloud-based storage to provide a secure integration between an organization on premises and IT enrollment and AWS storage infrastructure. So it's act like a on-premises data center to AWS cloud for a storage purpose. So this gateway will allow you to connect with the AWS cloud storage platform. And AWS Snowball Edge and Snowball Move is used for example, um, as AWS Snowball contains the compute at the same time the storage space. Whenever you are transferring your data from on-premises to cloud, for example, it's a GBs, then data can transfer to network. If it is petabytes or terabytes of data is available, at the time we use a Snowball Edge location, Edge device, which is shifted from Amazon Office to your location, and it is fully encrypted with 256-bit encryption key is available. There you can transfer all the data of your existing production data to Snowball, and Snowball straight away shifted to AWS data center. There, AWS team is connected to their AWS cloud, and they will transfer the data which bucket is your preferred. And the same concept is in AWS Snow Mobile, but it is as a huge big truck. Uh, it is allow you to transfer the petabytes of data. For example, in Netflix, you can take Netflix has a huge content of movies and all. So that much of petabytes of data can be moved by using a AWS Snow Mobile device. So it is huge truck, and the backend truck contains the full-fledged Snowball with a lot of connections and all stuff. Then you can plug into your data center and transfer all the data to AWS Snow Mobile. Then it transfer to straight away to the data center, and it is migrated in AWS cloud. So these are the AWS storage services what they are offering. And to understand what kind of database services are available in AWS, so there are the database services are available in AWS, something like relational database service and DynamoDB. You can call it as. So what is happening in Amazon relational database service? In Amazon relational database service, it supports 6 commonly used database engines like Aurora. Aurora is one of the thing, and MySQL and Oracle. They all call it as a relational databases. Like DynamoDB is a fast and flexible and NoSQL database service is available. And Redshift is used for it's basically used for a data warehouse service. When you have a petabyte scale data is there, and you can use Redshift as a data warehouse service. Yeah. So these are the database services are available, and whenever you are planning to migrate your data of Oracle, there are other services are available like Amazon Aurora is available, Aurora database, which this Aurora database can give you flexibility in terms of licensing policy. For example, in Oracle, we know that we pay the licensing for by core basis, and there is another top of the service support services available. But in Amazon Aurora is no need to have any licensing policy first thing, and you can have a 1 year free credits are available to use Aurora database once you migrate it completely to from Oracle to Aurora database and AWS database services. So these are the flexibilities Amazon gives. In case you have any opportunity, we can discuss, and we can give you the more advantages on what is Amazon Aurora can give you the more benefits. So these are the simply we can brief about Amazon relation database services like Amazon Aurora as explained, MySQL, Postgres SQL, and Oracle SQL data services, and MariaDB, and fully managed and zero admin request. So in case of you're running the Oracle or MS SQL databases, you are having a licensing issue, paying huge money to the companies, then why don't we use Amazon Aurora service to migrate our database from on-premises to cloud, and there you can save huge money in terms of cost, and that money you can spend on different business use cases. And this is my last slide. We are talking about advanced services. Uh, uh, we have discussed about compute services and network services and database services, and we also discussed about storage services what they offered by AWS. This is the basic services we generally in and out we see whenever the requirements are generated. That's the reason we have covered a lot. And apart from that, we have 200 plus services we explained earlier. So those also available on case to case basis with changes. So these are the 200 based services. In that I can pick up like enterprise application services like virtual desktop. We have something called workspace. Uh, we call it workspace, AWS workspace. There you can get a virtual desktop. So in this case, whenever you have a requirement of a 50 user desktop purchase or something, you can use and this price also very comparatively a desktop cost when compared with virtual desktop is much lower. And for example, you are temporarily you want to hire some desktops for working for some particular project, then you can take a virtual desktop service from Amazon. It can be available with the Windows, and also Amazon Linux model is available. On choice of your operating system, you can choose and you can run your application on the virtual desktops, and you can finish your end user tasks. In that case, you have something called machine learning. You want to run any machine learning ML tools or something, readily available platforms are available in AWS where you can use and you can utilize the service. Like that, we have other components for security, compliance, and we have something called a marketplace also there, where you can use your own choice of firewall services. For example, you are currently running with firewall from FortiGate. If the license is allowed you to use from cloud based license, if the on premises license is able to migrate it to cloud based, then we can use the same license to use a Fortinet firewall from the Amazon cloud as well, while you are creating a security firewall feature. So like that, in marketplace, there are other solutions are also available to back up your data from your on-premises to S3 bucket. Something called Veeam is also available, and Commvault also available for doing that task. So in marketplace, there are the availabilities, and the other software is also available in marketplace on your choice. Whenever you required only infra from EC2, like EC2 instance GBS volume, and you want to run some particular applications, and you can easily can hire some software from marketplace, and you can utilize them on AWS platform. So this is all about AWS services, and a clear idea about what we do and what are the services we are offering. Uh, Anything we can reach us on emails. We are available for you to address your queries, to understand your infrastructure. If you need any further services, you can definitely reach us. You're trying to launch any new application, you want planning to migrate any applications to a new hardware requirements, definitely you can contact us. We can give you a brief idea and what is the ROI you can see in the future. All the benefits we can clearly explain to you. Thank you for joining with us today. I'm done. Janet?
Yeah,
Yeah, my topic is finished. I think Alabi can take it over.
all right. Hi, Alavi, are you able to hear me?
Yes, Alavi. Sorry, Alavi is my colleague from AWS. He is going to present you about
Can you hear me?
backup and DR services. Yeah, yeah, we are able to hear you, Alavi. I'm going on mute.
Can you hear me?
Yeah,
Yes, yes,
Alavi.
we can.
Yes, Alawi, we can hear you. Go ahead, please.
Excuse me, can you hear me? Yes, Alavi, we can hear you. Okay,
Yes, we
thank
can
you.
hear all of us.
Thank you.
I have some issue with my audio setup. Sorry for this. So
No worries.
before I,
And we
yeah,
can see your screen as well. Yeah.
okay, so that's good. So before I continue the session around the disaster recovery, I want to answer this question regarding the workspace. So yes, you where you will be charged only for the time that you are running, with very small charge for the period that the machines are idle. So it's two options, either always on or the on demand. And then if you go to the website, you can find the pricing calculator, easy to estimate the cost. Now, another question, what will be the prerequisites for infrastructure as a service? There is no prerequisites as such. You will be able to create either Windows or Linux machine, and you will be able to connect to it remotely within minutes. Automatically, the ISO file for the Windows versions and the Linux distributions are available. In some rare cases, you might have your own image. You can upload that image as well, and then you build your custom AMI. AMI stands for Amazon Machine Instance. This is the, let's say, the base or the template that you can start from it, machines or infrastructure services. So if there is any other one, can switch to the disaster recovery. How the replication will happen from on-premise? This is another question. So replication is actually two scenarios. One is for migration and one for disaster recovery. So the one for disaster recovery, I will cover it in my session, in my presentation. But for the migration, typically for files, we have different technologies to replicate or migrate file shares and local files. So the most common one is called directory sync or their sync. This is like progressive replication, continues to replicate on the background until all data is being replicated, and then you can run like a final replication check to replicate any changes that would happen between the start time and the end time. Regarding servers replication or let's say disaster recovery, this is the one that I'm going to cover right now. So forgive me if I don't see the question and answers because I'm going to do the presentation. I'll come later after the session to cover any question that you might have. So I would like really to start first by thanking Redington and GBS for giving us the opportunity to present AWS solutions. My name is Alawi Elbar. I'm a senior solution architect with the AWS. I want to cover today basically the disaster recovery options that we have. But before, I want to touch base on what we call the migration acceleration program. This is something that we work with our partners to help customers in their journey to migrate to the AWS cloud, because it's really like a long and somehow complex journey. We try to either make it simple for customers or to accelerate the migration in case customer has mandate to, let's say, migrate off a local data center. And then we'll talk about the setup, how to start whether a migration project or disaster recovery project. So you'll start with something called hybrid cloud setup. This is where you will establish, for example, secure connections between your on-premise data center or your head office or sites and the AWS cloud, as well as extending your Active Directory, because most likely you want to continue using your existing authentication and authorization mechanism and provide users with single sign-on experience, whether they are accessing resources on the data center on-premise or on the AWS cloud. And then I'll go in deep dive on our disaster recovery solution. It's called Cloud Endure. And then we'll answer the questions that you might have. So the MAP, the Migration Acceleration Program, is a set of methodology, a framework that we use for migrations, as well as tools. And so with the methodology, we recognize the maturity, the readiness of customers' team, of let's say, applications prioritization. So we would really establish a plan, a phased approach plan that will guarantee the success, reduce the risk, and of course, try to reduce costs and time as well. Now, framework are good, but tools are also important because we need automation. So we have our own tools, something called Migration Hub, Application Discovery. All of these tools help in providing the initial assessment as well as some of the migration tasks. But also we have partners tools who can do even some, let's say, better capabilities in special areas like in application discovery or prioritization. So we work both with our native tools as well as third-party tools to provide seamless experience for the migration. And then finally, of course, needing help. So extending our capability as a AWS team. We have GBS as our extended partner to provide the professional services needed for you to do the migration and or disaster recovery projects. And of course, training is crucial for your team. And there is a big shift really to the cloud. So it's not only about just moving an application from on-premise to any public cloud. It's about the operation. It's about the process. It's about even the skills. So from operations perspective and process, I hope that you heard about the DevOps, development operations. So traditionally you have development isolated and segregated from operations. And there are many frictions happens in between. So when let's say business people try to request new features or new applications, development tries to push applications code into the production, but then operations need to guarantee the availability, the security of new applications. And this really, let's say, delays the adoption of new technology. So the business becomes really frustrated. Like, it is taking a long time from IT, even though they are making big investment. And sometimes some organizations actually, they make decisions to go to the cloud bypassing the IT. There is a term called shadow IT, meaning that there are part of the business running outside your control, your monitoring. And this is the shadow IT, which means the public cloud. So what we advise here customers is to adopt the DevOps. This is basically an integration between the development or the applications team and the operations so that they work as a one team. So this means there should be a transformation in the IT operation as well. So this is why training becomes very important. In order to transform the IT operation and help your organizations in their digital transformation initiatives, both teams, applications, network security, infrastructures, all of them need to work as a cloud team. And the reason for this, because cloud provides complete automation of the infrastructure. There is a concept called infrastructure as a code, IAC, meaning you can program even the provisioning or the upgrade of your infrastructure, including security, including network setting. And this is where, again, training plays an important role. And one advice that I can give to IT operations team or engineers and consultant is to start building skill set on scripting. I cannot stress this more than this. I mean, in the cloud era, if you don't have scripting skills, most likely you will be irrelevant. Yes, we were happy for the past decade or more using configuring our services using graphical user interfaces, whether it's web-enabled configurators or the Windows. But the move to the cloud requires this DevOps, the continuous integration, continuous delivery of IT services, of applications features, and scripting is the core. It's at the heart of how you manage your infrastructure in the cloud. I just wanted to really highlight this for our IT heroes. And of course, as AWS, we provide certifications. So typically, we have solutions architect certifications and DevOps certifications, and then some specialties on security, on database, on even machine learning. So these are something like it's good for career point of view. Now, the first step really to do any migration project or even disaster recovery project is to establish a hybrid connectivity or a hybrid cloud. So the hybrid cloud means that in your own data center, whether it's on-premise or it's co-located, we need to establish a VPN connection to your AWS environment. So as Viday mentioned, the VPC is your virtual private cloud. This is your secure, isolated area in AWS cloud to host your mission critical applications, and you can have your own subnets, whether it's public, private, and even from high availability point of view, when you start deploying your applications, we would recommend you to distribute them across data centers. So they will be in different availability zones in order to increase your SLA very much. You know, today you are implementing a cluster, let's say, of active, passive in one data center. If the active server is down, then the passive or second server will take over automatically. But this is only high availability. This doesn't provide you, let's say, a business continuity if the main data center is down. In this architecture, you can stretch your cluster between two data centers in two different availability zones. So your active will be in availability zone 1, your passive in availability zone 2, and the latency is here sub-millisecond, meaning that it's not noticeable for the application server. So the primary will be in one data center, your user's traffic will be directed here, and then if there is failover, the user traffic should be redirected there. Now, when I say stretch, I don't mean VLAN stretching or layer 2 stretching. No, we don't do it. It's a matter of that you designate your primary server in one subnet on this availability zone and your passive server on another subnet on this availability zone. So again, this is a very, very interesting capability on the cloud. And from storage point of view, your data is replicated in synchronous manner. So you really don't need to worry about data replication. Only the servers need to be placed across two availability groups. Again, coming back to the migration and DR, so the establishing the IPsec tunnel between your data center or your different sites, so it's not necessarily to be only in your data center, is that we provide for you a virtual private gateway that allows you to connect your router or firewall using standard IPsec protocol with good encryption in order for you to have this secure connectivity. Now, from our point of view, the virtual private gateway is also highly available. So it's available across the region, whether it's having 2 availability zones or 3 availability zones. We will provide you endpoints that are accessible across all availability zones, as well as providing to you 2 tunnels routes. So the recommendation typically is that you have 2 routers or 2 firewalls, each connected with different ISP, and then both terminate to the same virtual private gateway virtual IP, so that you can have backup backup VPN link in case one internet upstream is down, then the other will take over. Of course, here we'll use BGP routing to provide that failover automatically, but also we support static route for, let's say, simple environment like proof of concepts. So this is the first step, is to establish the hybrid connectivity between your data center and the AWS cloud. The second thing is to extend your Active Directory that is in your data center. So you would have your domain controllers, global catalog, also serving DNS. You would establish additional domain controllers on the cloud. And then there are different options here. You could use the same domain and host your AWS applications on the same domain, or create something called Managed Active Directory Services. Actually, it's beyond the discussion of this session. But the idea here is that you want to minimize the changes or updates on your core domain controller, and you create a new domain forest. You call it resource forest, and your domain become your account forest. So when you establish the trust relationship, you know that you are trusting your original domain for the new managed domain on AWS, and then you again establish your application server, or their remote desktop gateways or application servers joining the machine, the managed Active Directory services on AWS, relieving you from any changes in your original domain forest. So these are again some of the options that we can discuss in details based on your case. So for Cloud Endure, these are like the benefits that we offer with our solution. So it provides you really an automated, orchestrated solution to provide disaster recovery or business continuity for your mission critical servers. And it is really reliable from fail over perspective. So whether it's an planned or unplanned failure that is happening on the data center or on the link or even on the individual servers, then you can assure that you will be able to recover in fast manner with the lowest RPO possible. It's almost near real time. Although it's asynchronous replication, but it's very sub-second RPO. And in terms of RTO, the automation can really recover within minutes your application servers. Of course, if the application server has many tiers and has, let's say, requirements to start, for example, databases, ensure consistency, and then application servers, and so on and so forth, then the RTO will be longer, depends on those additional consistency checks or checkpoints. And of course, there are many other use cases for DR, like, for example, if you have corrupted data or some attacks on the original servers on-premise, the replicated data on the cloud will have snapshots, point in times up to 10 minutes. So every 10 minutes, you could have a recovery point so that you can really bring your applications to a consistent state in case, God forbid, you got any corruption or ransomware attack. And again, because it's orchestrated, it doesn't really require I would say it doesn't require even additional training for your team. It's a graphical user interface based. You can just put your DR plans, establishing the order of the service to be running, and put blueprint how you want to recover the machines, and then forget about it. You don't act on the console until you want to do either disaster recovery test, like DR drill, or you want to actually activate your DR plan. We'll come to these concepts in coming slides. So this is the architecture of the Cloud Endure. Cloud Endure is a company dedicated for migrations as well as DR, and we acquired it last year, earlier in 2019. So we have the console on the cloud. This is SaaS service. And we deploy agents on your servers on-premise. And if you have a vSphere environment, instead of deploying agents on the individual virtual machines, we can deploy a virtual appliance on vCenter so that it manages the replications and orchestrate the failover, failback for the virtual machines. But for physical servers or for even Hyper-V virtualizations, you have to deploy the agents manually on the protected machines. And then on the AWS side, we would have two subnets. One is called staging area, and one is called the target area. So what happens is that when you deploy the agent on the machines, or you use again the vCenter appliance if you are using vSphere virtualization, the agent will start replicating each disk that is attached to the server, block by block, to the staging area. In the staging area, we will not create a server with the same specification. Instead, we'll create a very lightweight Linux server that is only responsible for receiving the replicated block disks. And it will write it into EBS volumes. EBS is Elastic Block Store, as Viday mentioned. These are our operating system, let's say, disks or database disks. But these are non-active disks, just receiving continuous replication from your source servers without, again, impacting the performance of the source server or application, and sending continuous replication and then storing them on EBS disks or EBS volumes. The option For the EBS volumes could vary. It could be SSDs. It could be even magnetic. So we have a type of disk that is called throughput optimized, which is very cost effective, especially for the disaster recovery scenario. And it can save these data, keep continuous replication in real time to make sure that you can recover at any point in time. So again, as you can see, your cost only is throughout the whole year is the disk storage for your original servers. We don't require any machine to be running here to receive your data. It's only this lightweight replication server, and this is sometimes called a lightweight pilot DR or DR in some terminologies, because you don't have running machines like in terms of application servers or database servers on the DR side. And this is just to receive the real-time data replications. Of course, the agent has intelligent protocol providing compression, providing even encryption in case if you want to do the replication over the internet without VPN. It's also possible in secure way. But of course, we recommend to establish the IPsec tunnel as we mentioned. Now, this replication continues in the background without interrupting again the original server. And at some point in time, you might want to test your DR. So this is the first step, is you want to test if this replication is correct, if I start my recover server with the application and database work or not. So in the target subnet, you can assign a test subnet so that it doesn't conflict with anything on your AWS environment, and then launch from the same disks here an instance using a snapshot. So we'll take a snapshot of these disks and create an instance on this target subnet while the replication is continuing. So we will not stop the replication, because what we are doing only DR drill or DR testing. So this is the moment that we do conversion. So we convert, let's say, from your vSphere format or Hyper-V or even physical drivers and servers on EC2. This is the virtual server machines that we are running on our cloud. So this conversion takes also minutes, and then it runs your recovered server up to the last point on that replicated data. So during this test, you test your database, you test your applications, you ensure that they are functioning. And of course, during this test, you will be charged for the on-demand pricing of those EC2 machines, and of course, the new EBS disks that are running your test machines. And of course, on the test or the production failover, we actually recommend to have SSD disk for a production grade performance. But again, the staging can be on a mechanical disks. And then, of course, once you are finishing the test, you can shut down the machines and just rely on the continuous replications for data, and because this is what you will be charged throughout the year to keep your data up to date. Actually, I have a slides that do the animations for you, and we'll discuss it in more details in subsequent slides. So what do we support? We support major operating systems and major applications and databases, as you can see. And something that we also brought to support is the Microsoft clusters. If you are running, for example, file shares or SQL clusters, we can also support it. But with one caveat, is that when we do the replications from the Microsoft Windows cluster, we only replicate from the primary active cluster node. And then when you recover, you will break actually the cluster. So we'll recover only a standalone instance of your SQL or your file share. But this is, again, some of the capabilities that we provide versus others. As you can see, we also support a wide variety of operating system, even non-supported operating system by Microsoft still supported, especially if you are running legacy applications all the way to the latest Windows 2019. And from source infrastructure, again, physical servers, Hyper-V based, any other cloud, as well as vSphere. And vSphere, as I mentioned, we have the vCenter appliance that can automate many of the tasks for the replication and failover, failback. Some of the references and successful customers with the Cloud Endure and AWS Cloud in general is, for example, this company, Malibu Boats. they were able to reduce their time RTO by half. And this is something that was one of their targets. They find that they can reach a better RTO as well, with much more lower cost compared to other solutions. Because as we discussed, it's only relying on low cost disks, something like magnetic disk, to keep the replicated data, and only you get charged once you activate the failover for testing or actual failover. So again, there are many metrics here, as you can see, whether it's cost, performance, RPO, RTO, many benefits that customers really gain when doing disaster recovery using AWS. So this is the workflow for the failover as well as recovery. So assume that you have standalone servers, whether it's Linux, Microsoft, and I'm mentioning here something for Oracle as well. So some Oracle servers requiring disaster recovery like Exadata. In that case, Cloud Endure cannot support it. We have other technologies or other workarounds to support such special purpose database servers that we can discuss in case by case. But generally, for standalone Linux or for Microsoft workload, including again the clusters, is that you have your own servers, standalone application servers, database servers, file servers, and then using the VPN connectivity, we'll establish a VPC, virtual private cloud, for you, establish a staging subnet. This is where we'll have the replication servers that will do the continuous replication for your data, and then private subnet that you can use for testing or actual failure. Agent will be deployed, the Cloud Endure agent, and it will start doing the continuous replication into a Cloud Endure replication server. And this is, if you recall, a lightweight Linux server. And for every protected machine, we'll have a separate replication server, so that from throughput point of view, from failover point of view, it will not impact multiple servers. Every server will have its own replication server. Now, as you can see, every disk will be replicated in its own throughput optimized disk on this staging, and this is the one that you'll be charged throughout the whole year, which is very cost effective if you do the calculations. Now, in case you have unplanned or planned failover, your continuous replication could be there if it's planned, or if it's not planned, then the latest committed replicated here, we can do the failover activation. Again, it could be only for testing or actual failover. And during the activation, we do converging. So we convert from the source operating system architecture or the virtualization architecture into the EC2. And as you can see, we convert even the disk type from the HDD type, the mechanical, into the SSD type for faster processing. And these are general purpose. We have even a higher throughput, what we call provisioned IOPS SSDs. This is for really high performance databases, which with, of course, additional charges. But this is the most common for most production servers, is the general purpose SSD. So this process takes minutes to convert the disks into the new format. And then the Cloud Endure will have a blueprint. The blueprint defines how you will bring up your recovered machines. Do you want to recover them with the same configuration, the same size as the original one? So typically in testing DR drills, you don't require really the same specification in terms of CPU memory. So you could have blueprints that only take small percentage of the specification. So for example, if the memory is 32 and the CPU count is, let's say, 8, you can have it as only 2 CPUs, 8 GB RAM. So you reduce make it only 25% of the original specification. But of course, if it's actual failover, then the blueprint should match the original server so that it can absorb the user traffic when you redirect it to the DR site. But again, this is flexibility you can have in order to optimize your cost more and more. Once you have your recovered servers up and running, again, you can respect the order, like for example, start the database, then the front-end application server, then the file share servers, whatever order you want. Once you have it, then you redirect your traffic to the DR site, which is in this case will be AWS. And then, of course, this will become your live data. This will become your production site, your primary site. And when you want to recover back, you establish what is called prepare for failback, so that the servers, the Cloud Endure servers, will reverse the replication from the AWS servers all the way to the origin servers. And this is important so that you can reduce your time and bandwidth requirement to do the recovery. Because the faster you do the failback replication, reverse replication, the shorter time, the less bandwidth that you will need to replicate back and then bring back the primary site to become active again. So this is some of the workflows that you can think about. And it's easy really to start with the Cloud Endure. You can go to AWS console. You can subscribe to the Cloud Endure. It costs you $20 per month per server. So very cost effective. That's from orchestration point of view. In addition to that, there will be the disk capacity. Again, it can be the throughput optimized, which is mechanical disks, which is very cost effective. And then finally, of course, the professional services cost to help you in establishing the DR plans and testing it, of course, doing the commissioning before going live. So this was really a quick and short introduction about Cloud Endure. I hope you find it useful. If allow me, I'll go back to the questions and answers.
Anyone would like to have any clarification, any technical support, or any information about AWS, you can communicate with our technical team in GBS. Or our help desk already, all of them, they are qualified for to answer your questions and reply to your needs for cloud requirement. Thank you very much, and we value your attendance today for this event. Thank you very much.